Welcome to the Carbonfly tutorial series. Carbonfly is an easy-to-use Python library and Grasshopper toolkit for CO2-based CFD simulation to analyze indoor air quality. This video demonstrates how to use ParaView to perform basic post-processing and visualization of Carbonfly simulation results. The ParaView version used in this video is 5.13.2. Here we use case 6 as an example. This case features a room with an indoor AC unit operating in recirculation mode without fresh air, plus a breathing mannequin model. After the simulation finishes, you will find the results in the case folder from 0 to 180 seconds saved every second. Double-click the .foam file automatically generated by Carbonfly to open it in ParaView. If you haven't installed ParaView yet, please refer to our previous tutorial on how to install it. If you're using the portable version, the first time you double-click a .foam file, Windows may not know which program to use. In that case, you can manually specify the ParaView executable. Select. Choose another app. Then locate the ParaView folder in File Explorer. Open the bin directory and select paraview.exe. Since we already have ParaView open, we won't confirm it again here. Back in the ParaView window, the first step is to load the mesh and the model patches you want to display. We'll show all model patches except groups/wall to avoid duplicate rendering. Click Apply to confirm the settings. After loading, you can select which field to display from the menu bar above. Carbonfly outputs several fields including CO2, temperature, velocity, and pressure. Let's start by showing the model in solid color to inspect the mesh. You can also color the model based on its internal regions. Switch the display mode to feature edges to show only the model boundaries. This makes it easier to visualize the internal results later. Next, we'll convert the CO2 volume fraction into the commonly used ppm unit. ppm stands for parts per million, so here CO2 is multiplied by 10 to the power of 6. From the top menu, select Slice. Move the slicing plane with your mouse or enter coordinates on the left for precise positioning. You can switch between 3D and 2D views. In the left Properties panel, set the color range for the CO2 ppm field. Set the lower limit to 600 ppm. Slightly above the typical outdoor level of 400 ppm. Set the upper limit to 1200 ppm to better visualize the gradient inside the room. Disable automatic rescaling of the range. Choose a suitable color preset. ParaView provides many built-in color maps, and you can also customize your own. Click the play button. ParaView will animate the simulation results over time. 1 second per frame in this case. Because the AC operates in recirculation mode without fresh air supply, you'll see little overall change in CO2 levels, only local variations from breathing. You can select any specific time step from the drop-down list. Switch to the temperature field to observe airflow and thermal distribution. Switch to the velocity field to visualize the airspeed more clearly. In the Properties panel, you can adjust the appearance of the color legend. For example, font type, size, and layout. You can also change the label number format. Here we set it to 1 decimal place. ParaView supports LaTeX syntax for text input. You can use it to create subscripts, superscripts, or other mathematical symbols. Now let's overlay a glyph plot to visualize the velocity vectors. From the Filters menu, select Glyph. Choose 2D mode 2D glyph. If you only want to see airflow direction, disable scaling arrows by velocity magnitude. Adjust the scale factor for clearer arrow density. You can also enable automatic arrow scaling by velocity. Arrow colors can also follow velocity or any other selected field. Since we're visualizing both CO2 and velocity, a second color legend appears. Drag it to a suitable position. Adjust the legend font, size, and unit label for velocity. The velocity unit is meters per second. Fine-tune the layout as needed. In addition to the buttons in the toolbar, you can also right-click to access many of ParaView's advanced visualization options. Now we'll add a filter to show the current simulation time, called Annotate Time Filter. Just like the color legend, you can customize its font, color, and position. Place the timestamp where you prefer. Play from the beginning to preview the animation. From the upper left menu, you can export the current visualization as an image sequence. First, create a folder to store the exported frames. Select the output path and set a common file name prefix. In the pop-up window, specify image resolution, compression level, and file format. Click OK to start exporting frames. Let's switch to the temperature field and export the temperature visualization as well. For more advanced ParaView operations, please refer to the official tutorials and documentation of ParaView. Thanks for watching.